Hello everyone, let's start our today's video with the topic vector form of Coulomb's law. So recently we had done Coulomb's law. What it said? It said that magnitude of electrostatic force of attraction or repulsion between two charges is always directly proportional to product of magnitude of charges and inversely proportional to square of distance between them. So that was only what it was. It was F is equals to K times Q1 Q2 by R square. That was only the magnitude form of the force. But in this video, we are going to cover vector form of Coulomb's law. Now, vector form of Coulomb's law, first of all, comes to the representation of a vector. A vector is always represented by this. A is a vector. It's represented by a magnitude, that is A, and a direction, A cap. This A cap gives the direction and this A gives the magnitude. So vector is what? Magnitude into direction. Magnitude into direction. Now A cap just represent direction here. It do not have any kind of magnitude. So the magnitude of this A cap is unity. Magnitude is unity. Of this A cap is unity. So for the vector form of force, we need what? Magnitude of force into direction. Magnitude of force into direction. So let's start with F12 vector. This F12 vector represents what? This represents force on charge 2 due to charge 1. Force on charge 2 due to charge 1. And this F21 represents force on charge 1 due to charge 2. Force on charge 1 due to charge 2. Now, if force, this F12 is force on charge 2 due to charge 1. F12 is what? Force on charge 2 due to charge 1. Means 1 for charge 1 is executing force on charge 2. So charge 2 is going to what? It's going to displace toward charge 1. If I am standing here, if I am executing force on a particle, I am trying to attract it toward me because this is positive charge, other one is negative charge. So this positive charge is going to attract this negative charge. So if body is going to attract other body by applying force, then that body is going to do what? It's going to displace from this point to this point. Similarly, if charge 1 is executing force on charge 2, then charge 2 is going to displace from point 2 toward 1. So displacement is what? R21. This is what? This is the displacement from point 2 to point 1. So if force F12 is active, means this is in this direction. This is force F12. And displacement is also in this direction. This is R21. So if you want only the direction only, then we write R21 cap. So what is the vector form of the force then? F12 vector, that is equals to magnitude. This was the magnitude, we already know. R is the distance between these two forces. Q1 is the magnitude of this charge. Q2 is the magnitude of this charge. According to the definition, we are going to take only magnitude. We are not going to take this sign. So Q1 Q2 by R square. Now here this is the magnitude. Now we have to represent what direction? Direction is R21 cap. Instead of vector, we will write R21 cap. If we want to write here R21 vector, then it will become R cube over here. So that is not required step. So we will stop up to here. This is force on 2 due to charge 1, and this is given by this equation is 1. Now similarly, F21 is what? This is force on charge 1 due to 2. Now 2 is going to exert a force on charge 1. Now charge 1 is going to displace from point 1 to what? Point 2. So displacement is from R1 to 2. This is complete displacement. If we want to take only magnitude, that is R1 to cap. Then again force is equals to magnitude. This is the magnitude into direction, that is R21 cap. Now this R is the total distance between these two charges. Now R21 is in this direction from 2 to 1. R12 is in this direction. So these both are opposite in direction. R21 is equal to and opposite to R21. So if we replace R21 in equation 2 by minus of R12. So from equation 2, and 3. Let this be equation number 3. From equation 2 and equation 3. So by combining equation 2 and 3, we get what? F21 K times Q1 Q2 R square. Now instead of R12, what I have right, that minus of R21 cat. Now from the this is now third equation. Now again taking the first equation, which was this. Now comparing this and this. K Q1 Q2 Q2 R square R21 cat. So this left hand side it's going to be same. If I take minus sign this side, then this side, right hand side is same, then left hand side is also same. So we get what? F12 cap is equals to minus of F21 cap. So which obeys Newton's third law of motion. So we can also say that vector form of Coulomb's law obey Newton's third law of motion in this equation. So now let's discuss the direction of force in Coulomb's law. If both the charges Q1 and Q2 both are positive, if both the charges are positive, in that case, force on 1 due to 2, force on 1 due to 2, that is written by F21. So this is force on 1 due to 2, or 2 is applying force on 1, 2 is applying force on 1. If 2 is applying force on 1, this is positive, this is positive, this is going to repel. So F21 is in this direction. Now force on 2 due to 1, that is F12 means force charge 1 is going to apply force on charge 1 is going to apply force on 2. In that case, now again this is positive, it is going to repel it. This is in this direction, this is direction of F12 vector. Similarly, in this case, this both are again like charges. Charge 2 is going to repel 1 in this direction, that is F21. Again this is force due to 2 on 1. Again on this F12, force on 2 due to 1, so 1 is applying force on 2. Now in this case, charge 1 is positive, other charge is negative. Now first charge 1 is applying force on 2, that is F21, it's going to attract it. So this is the direction of F21, 1 to cap, that is force on 2 due to 1. Now this 2 is going to again attract 1 toward itself, so this is force on 1 due to 2. So this is force on 1 due to 2. And again, what we observe from here, this force is acting along the line joining the center of 2 point charges. This is the line joining the center of 2 point charges, and this force is acting along this line, either inward or outward, So as this force is acting along the line joining the center of 2 charges, so this force is also called central force. This force is also called central force. It obeys inverse square law. Which law? Inverse square law. Why so? Because F is inversely proportional to 1 by R square. That's why it's obey inverse square law. This force is attractive or repulsive. Now limitation of this. Now Coulomb's law is valid only for the point charges. Means it is valid up to microscopic level, not at the macroscopic level. For the point charges it is valid, not for the continuous charges. Now in the next lectures we will discuss about quantity sector and so on, charges and so on. So it is valid only for the point charges.